Hi folks, welcome to 6.6 Inverse Trig Functions, part 3 in the video. So what we're going to do right now is take a look at what happens when we are trying to not come up with an actual number answer like we did in 1, 2, and 3, but actually come up with an algebraic expression, okay? So we'll take a look at this with two examples, and let's start right here with part A. So part A says that I have the sine of the inverse tangent of x. And just like we did in example 3, I'm going to suggest that we start with a right triangle and label all our sides. So I'm going to go ahead and draw a right triangle and label my angle theta. Now I know that tangent, whatever's being tangented, is my opposite over adjacent. And since I just have x, I can actually leave that as x over 1. So in my right triangle, the opposite side from theta, I'm going to put an x. And the adjacent side to theta, I'm going to put a 1. And just like before, I'm going to use my Pythagorean theorem to find the missing side. So I've got 1 squared plus x squared equals c squared. And because I can't combine those terms, I can just say that c equals the square root of 1 plus x squared. And that's what I'm going to label on my hypotenuse, 1 plus x squared. Okay, now what do I want to write? I want to write the sine of that angle. So that is going to give me, sine of that will give me the hypotenuse, not cosecant, sine, opposite over hypotenuse. And so that's going to give me x over the square root of 1 plus x squared. And that's just how we'll leave our answer there. Let's try part B. Part B, the tangent of arc cosine of x. Now, I wanted to use the other notation because some textbooks will use arc cosine, some will use the -1, and I want you to know that they're the same. So if we're looking at arc cosine, that means I have adjacent over hypotenuse, which is really x over 1. So I'm going to draw my right triangle, label it with my theta. The side adjacent to that angle is x, and the hypotenuse is 1. And I can use my Pythagorean theorem, a squared plus b squared equals c squared, to find the missing side. So I've got x squared plus b squared equals 1 squared, or b squared equals 1 minus x squared. And so I can say that this missing side is the square root of 1 minus x squared. Now, what am I looking for? I'm looking for tangent. And so I know that tangent is opposite over adjacent. So what's opposite from my theta? Well, square root of 1 minus x squared over what's next to my theta, or adjacent to it, and that's x. And there I have my algebraic expressions that represent a similar process as number 3, but this time I just don't have exact numbers. Okay, let's move on to part 3, solving trig equations. So we can also use arcsine and arccosine and arctangent to solve trig equations. And we've actually been doing that so far, but I wanted to showcase some scenarios where maybe they're not nice unit circle values, and maybe we do need to use our calculators a little bit, okay? So we're going to call this first one here example number 5, and this is in your textbook. And so I wanted to just talk through how they got their answer, and then we'll go ahead and do an example together. So this one says find the solutions of this equation, and they only want answers between 0 and 2 pi. So before I even start, I'm going to go ahead and draw a unit circle and use that to help us figure out where our answers might be. So I have my unit circle, and we'll come back to that in a little bit. So if I look at this, I could really think about this initial equation as 5u squared plus 3u minus 1 equals 0, where u equals sine t. And maybe when I write it like that, it's easier to see that this is indeed a quadratic equation. And since it's not factorable, we're going to use the quadratic formula. And so in this case, if we take a look at this, I know that my a value is 5, my b value is 3, and my c value equals -1. And when I plug those numbers into the quadratic formula and I simplify, I get these two as my answers. But that's what sine equals. So to find what t equals, I need to use inverse sine. And I want to do it for the plus version, and then I want to do inverse sine for the minus version. And when we do that on our calculators, we get two numbers, 0.2408 and -0.9946. Now, if we think back to our unit circle, and we want to think, okay, I have arc sine. Arc sine means I choose from the right half of the unit circle, and my answers need to be between -pi/2 and pi/2. So what does the textbook say? It says, since the range of arc sine is -pi/2 to pi/2, we know that our first answer is between 0 and pi/2. And here's how you can check this. Turn pi/2 and -pi/2 into decimals. Let's see what we get. So pi/2 at the top is going to give me 1.5708, and -pi/2 is -1.5708. So let's see if our answers are between there. Well, 0.2408, that is going to be somewhere here. So that looks good. And this second answer, -0.946, is going to be somewhere down here. And those are both on the blue side, so they're both going to be our answers. All right. Take a moment to look over this, but we're going to use the same process to help us with one more example. So solve the equation cosine squared x plus 2 cosine x minus 1 equals 0. And again, we want solutions that are in one rotation of the unit circle. So let me go ahead and set up that unit circle because we know we're going to need it. And because we're looking at cosine, we know we're going to need to pick from the top. And this is 0, and this is pi, or we can think about that as 3.1416. Okay? So our answer should be between 0 and 3.1416. Okay. Just like before, we're going to use a u substitution to show us that it's quadratic. We'll get u squared plus 2 cosine x, u squared plus 2u minus 1 equals 0, where u equals cosine x. Now, what does that mean? We've got an a equals 1, b equals 2, and c equals -1. And so when we plug that into our quadratic formula, we're going to get -2 plus or minus the square root of 2 squared, which is 4, minus 4 times a times c, all over 2a. Now that simplifies to -2 plus or minus the square root of 8 over 2, or I can say that this is negative 2 plus or minus 2 root 2 over 2, which is nice because then I can write it as negative 1 plus or minus root 2. Now let's not forget that this is equal to cosine x, okay? So now I have to use my inverse trig functions to help me find what my x is. Okay, so I'm going to do this. Inverse cosine of negative 1 plus root 2. And when I type that into my calculator, it tells me that it's 1.1437. And 1.1437 is somewhere about here on my unit circle, so this one is good. Let's try typing in the second potential answer. Inverse cosine of negative 1 minus root 2. And when I do that, my calculator says error, and that's okay. It is not in the domain, so this one doesn't actually give us an answer. What we have to do, however, though, is make sure that we've got all of the answers between 0 and 2 pi, which means that we want to say, if we were to consider the whole unit circle, is there another angle that has that same x value? And it turns out that this angle has the same x value as this angle. So now this one is 1.1437 comma something. So I need to figure out, what do I say about this angle here? And what I get for this one is that it's going to be 2 pi minus 1.1437, or that will give me 5.1395 as my other solution. Now, I just want to clarify something real quick. This 1.1437 is this angle right here. And this 5.3 number, this one, 5.13, that is, if I start from 0 and I go all the way around to here, that angle measures 5.1395. Okay? So we need to make sure we find all those angles in there, and I definitely find a diagram helpful in solving that. Okay, folks, so that's it for 6.6. If you have any questions, shoot me an email, send me a message on Canvas or on WebAssign, and I'd be happy to help you out. Thanks so much.